Hello everyone, let's continue with the Sean Prasad list by solving a pretty interesting question, squares of a sorted array, and there is a storm outside, so I apologize for any interference you might be hearing. We're given an integer array norms that is sorted in non-decreasing order, and we want to return an array of the squares of each number sorted in non-decreasing order. So basically the order in which it was given, it should be returned. But if we look at the example given, the square of this non-decreasing array is going to give us this, rather. That's minus 4 times minus 4 is 16, minus 1 times minus 1 is 1, and 0 times 0 is 0, 3 minus 3 is 9, and 10 times 10 is 100. But this is not sorted, this is not in non-decreasing order, and so we have to sort even the output given and get this returned. Now this is non-decreasing order, just basically means like in ascending order, right? I noticed this is something Leetcode will do a lot, or any coding interview really. Do not say ascending or descending, or rather say non-decreasing and non-increasing. So yeah, that just means that it's ascending, and there can also be multiples of the same number. For instance, we can have something like minus 4, minus 1, 0, 3, 3, 10. So basically, I think this is why they don't call it ascending, because we can have multiples of the same number and then it is not ascending, right? So this is non-decreasing order. So what are we going to do? Now the most intuitive form, right, is to square the values of the array, and we basically get this. Then after squaring this, we can use any sort method in any program language of choice. In JavaScript, that would be dot sort to get this sorted array. But that is going to give us a O of n log n time complexity, because sorting is going to, or rather, finding the square is going to take just O of n, then sorting is going to take O of n log n, and we know that O of n plus O of n log n is going to give us O of n log n as the time complexity. But this does not work. Because we've been told in one of the follow-up to the constraints that we should try to solve this in O of n time complexity. So we want to do this in a more efficient way, and how can we go about doing this? All right, so let's give ourselves some room and consider how we can approach this question. All right, so we're given an array with these numbers and we want to return their sorted squares. Now, since we cannot use the most intuitive form, which is to return an array with the values already squared and then sort it, we can use the two-pointer approach, whereby we get the middle value, right? Let's say this array is 5, so the middle is probably going to be the number at index 2. So this is left and then this is right. And then we compare the values. We check, okay, 0 and 3, which one is greater? We can get the absolute value, because we know that it's possible that some numbers are negative, so we can get the absolute, which is basically just getting the positive of whatever values we are given. So we compare it, which of these numbers is greater, 0 or 3? Obviously, which number is lesser, rather? 0 is definitely lesser than 3, so we can just go ahead and return the square of the lesser number and add it to our array. So that's going to give us 0. And then we can just go ahead and we're done with this. So we decrement our left pointer, right? So we decrement our left pointer to the next one, and then we compare again our left and our current right pointer, which is lesser, with the absolute, right? So the absolute of minus 1 is 1 and the absolute of 3 is 3, and we compare which is lesser. 1 is definitely lesser than 3, so we go ahead and return the square of minus 1. Then we go again, we are done with this, we move our left pointer to the left and we compare which is lesser between our right and left. Remember, we are comparing just the absolute, right? And the absolute says that 3, the right, is actually lesser this time, so we go ahead and return the lesser value, which is 9. And then we move this pointer all the way to the last one on the right, and then we compare the absolute, which is lesser between minus 4 and 10, and the answer is 4. 4 is lesser, so we go ahead and return the square of the lesser value, and finally the value of the last bigger number. Now this works fine, but there are some edge cases that this does not cover, and I will show you in a minute. So the logic we used kind of like assumes that there would be a lesser number, a middle ground and a greater number, right? But what if we had numbers such as 1, 2, 3, 4? Because our question says that the values in the array is non-decreasing. So this is non-decreasing actually, because this is actually an ascending order array. So this is fine. And in fact, let's even make it worse and just add something like 2, right? So this works fine. Now if we follow the logic that we used to sort this and get the value in O of n time, then we will get the middle number, which is also going to be this and this, and then we can just go ahead and check that which is lesser. Okay, so 2 is lesser between left and right, and then we return the square of 2, which is 4. Now we go ahead and we're done with this. We move on and we check, okay, which is lesser between 2 and 3, and 2 again is lesser, so return that square. We are fine so far. And then we move our left pointer again to the last number, and then we check, okay, 3 and 1, which is lesser, and then we can see that 1 is actually lesser and is lesser than all that we have been seeing. But we do not know that because we assume that our algorithm is correct, and because it worked for this problem whereby we have the we have the negative and positive number, this will work fine. But if we had just positive number, this algorithm is not going to work, because then we return 1, right? Because 1 is obviously lesser than 3. The absolute of 1 is always going to be 1, is lesser than 3, and then we are done. And then we kind of like say, okay, we have no left value again. We have 3. We see that, okay, we still have right value. So we convert 9, and then we move on to 16. Now this would have been fine, but we have all positive numbers, and that logic just doesn't work. So the formula we did, whereby we found the middle and then expanded from the middle out, only works if we are sure that we have negative numbers on the left and positive numbers on the right. But we are not assured of that, right? So is there any way that we can actually solve this problem? And yes, there is. Let me show it to you. So again, let's consider the values that we've been given. And let's just do our regular left to right pointer, right? So we have our left pointer, we have our right pointer. And then we want to check that, okay, we want to check which is larger. Is there a way where we can do a sort of reverse psychology with our code and work with the one that is larger? We push them to the back. So for instance, to actually picturize this rather than say it, we check left and right, and this is even going to be easier to write, because we know that our left pointer is going to be 0 and our right pointer is going to be the last element in the array. We don't have to start from the middle. Now we check, okay, which is greater between the left and right pointer. We can see that obviously the right pointer rather is greater, so we multiply that. 10 times 10, that's 100. We add it to the last index in the array, and then we move on, because it is greater, right? So we know that this works because the input array is already sorted. So whatever value is here is always going to be the larger value, and then we're pushing it to the end of the array. Now so we are done with this, right? And then we kind of like decrement it and we move over here, and then we check the absolute value. Remember, we always have to go to check the absolute value because it is possible that there are negative numbers. So we check the absolute value of -4 and 3, and -4 is greater, so we take the square of that and add it to the end of the array, but just before our previous value. So basically we'll be appending new values to the front. So you know, the regular array, we are pushing values to the back, and it's like new numbers keep coming. But in this case, we'll be pushing new entries to the front. So the first entry will be 0, and when there's a new entry, we push it to the front is 6. When there's a new 16, when there's a new entry, we push it to the front, and that way our array will be sorted, right? Then, so we have 16, and then move our left pointer. We compare our left pointer and our right pointer. Right pointer, the absolute value 3 is obviously greater, so we move 9 to the front again, and then we move our right pointer, and then we compare the left and right. Left is greater, so we have our left, and finally our right, and this is sorted. And this is done in O of n time complexity, because we are comparing the greater value, we are sorting it directly, we are arranging it directly in our array in a sorted format. Now the space complexity is going to be as large as the inputs. The output array is going to be as large as the inputs given. So now it's up to your interviewer, or you really, is the size of the input array negligible or is it not? If it is, then we can assume that we're using a constant space. But if it is not, if it's that any extra data structure, as long as it is no longer one or a variable, if it's that any data structure any storage count at all, then this will also be O of n. And in my case, I'm considering this as an extra data structure, right? Because we're not just storing a variable name that can be easily referenced, we're storing a whole input and we're returning that as an output. So this is O of n space complexity for me, but it can help to just discuss this with whoever is asking you the question. So are we going to ignore the fact that our output array is going to be as large as our input array, and that will guide you in your space complexity answer, but the time complexity is going to be O of n. Now let's try this with the second edge case, whereby all our answers, right, are positive. So we go, let's write that 1 2 3 4, and we want to have our left and right pointer. So when we have our left and right pointer, we can see that our right pointer is greater than our left pointer. So we get the square of this, which is 16. And then we move our right pointer. We see our right pointer is still greater than left pointer. So we tackle that, which is 9. We move our right pointer again. We see that our right pointer is still greater than left pointer, which is 4. And finally, we move our right pointer to our left pointer, and once our right pointer and left pointer meet or go over each other, we know that we've come to the end of the array and we return 1. And this works fine for all edge cases, and this is the technique we're going to be using. Let's jump right into the code. So let's write our Python code quickly, and the first thing I'm going to do is define our output variable. I'm going to be using the deck data structure, which is like a list, but it's a queue, like the inbuilt queue data structure for Python. And the purpose of using this instead of the regular list is so that we can append the values at the front, because as you can recall from the code walkthrough, we do not want to append values from the back, since we want to visit the larger number first, and so the largest numbers will be the last item in the array and the smaller numbers will be the first numbers in the array. So we want to push values to the array from the front, not from the back, and the queue data structure allows us to do that. And then we're just going to get define our left and right pointers. Our left pointer is going to be the first element in the array, and our right pointer is going to be the last element in the array, which is the length of nums minus 1. And so let's define our flow. So we want to run this as long as our left pointer is left or equal to the right pointer. Then we know that we've already looped through the entire array. Now let's also get the numbers at the left and right pointers, because that is what we'll actually be comparing their values, which is greater and which is lesser. So let's say we've already gotten the left and right, the index of the left and right pointer, the least number and the greater number. So now we want to compare the numbers, which is greater, and so we're just going to get in the numbers with nums left and nums right. And then we can just compare which one is greater, but recall that we are going to use the absolute to compare. If the absolute of right is greater than the absolute of left, then we want to go ahead and append left is the appropriate keyword to use with q. We want to append the square, so append right times right. And don't let us forget to decrement our right index. If left is greater, we want to go ahead and append the value on the left side. So the left times left, that's just multiplying the numbers. And then we're also going to go ahead and increment the right pointer. And at the end, we're just going to return our rest, that's the result, but as a list, because a list is expected, not a queue structure. So let's run our code and see what we get. This runs fine, which means that we can go ahead and submit it. Quickly, let's also look at our JavaScript code, and I'll be typing this out because I think that there are a lot of structural changes, like how we don't have the queue data structure in JavaScript and we have to use the JavaScript inbuilt method like on shift. So let's go ahead and look at what that looks like. First, we're going to define our results variable, our output variable, which is going to be a regular array, and then we're going to define our left and right pointers. It's going to be 0, and the right pointer is going to be the length of nums minus 1. And while we are in bounds, our left is less or equals to our right array, we first want to get the numbers at the left and right pointer. We're just going to do that with nums of L and nums of right. So we want to check which number is greater and push the greatest number far behind. We're going to check the math absolute of right. So the absolute value of right, if it's greater than the absolute value of left, we're going to go ahead and push that to the front of the array. Sorry, and we can do that using the unshift method, and we're just going to return the square or add the square of the greater value, and we are also going to go ahead and move ourselves a bit backwards. And also, if it happens that the left value is greater, we are going to unshift and add the value on the left pointer, and also increment our left pointer. We can just go ahead and return the results then, and I'm just going to straight up submit this, and hopefully it works. And it does. Thank you so much for watching. I hope you gained something. I'll see you in the next video.